Hello and welcome guys. So in the last video we did our model training and this accuracy visualization. So we are getting here 88% approx validation accuracy and training accuracy as 92%. Now in this video we are going to test this model. So first we have our model here. So let me see that. So yeah, so we have this model. If you want to see your model, then you can do model.summary also like this. And if you don't have this model, then first you have to train it, and if you save this model here, then you can load this model also here like this. So you have to use this thing tf.keras.models.load model you can use, and in this if you pass the path of this directly from here, copy relative path and give here like this. If you give like this, then you will be able to load your model, and after that if you do model.summary, then you will get these things. Okay, so this is how you can load your model from this file which you saved in the last video. Okay, so I'm going to test this model on some random text and see how it's behaving and whether it is able to capture the sentiment or not. Okay, so let me give here one markdown. So I'm giving here one markdown as testing model on random text. Okay, so let me take one example here first. So I'm taking one random text. Random text is equal to, I'm taking the movie was cool, something like that. Okay, so I will do my prediction directly. So I'm doing my prediction by taking this prediction variable and model.predict I'm using, and in this I will use numpy. So I have already imported that numpy. So np.array I'm doing, and I'm passing this random text. Okay, so this is what I'm passing. So if you want to see exactly what it do, so it will basically apply this. If you do like this, and I'm commenting this as of now, it will convert this string in numpy array. Okay, so this is what it's doing because we trained our model using these things. So using numpy array, so we have to convert in the same format, then only we can feed to our model for the prediction. Okay, so that's why we are doing like this. And let's see our prediction. If I'm doing here predictions, so I'm getting here 0.63, 0.6391. So this is what this is the probability I am getting. So in training set we have this example labels in 0 and 1. So we are applying this sigmoid function in the output layer. We are applying this sigmoid function. Okay, so it means that if our accuracy is greater than 0.5, then it means that it is positive prediction. Okay, and if it is less than 0.5, then model is saying that it is negative. So we have to apply this concept here. Okay, so that we can map exactly what this model is saying using this probability. Okay, so I'm saying here that if prediction is greater than 0.5, then say that it is positive sentiment with I will also give score. So with score as score you can give something. So score will be prediction. So prediction, this is a two-dimensional matrix, so I will take 0 and 0. Okay, and if it is negative prediction, else I can say it is negative prediction. So I will use same thing, only I will replace this with negative prediction, negative sentiment with score something, whatever we will get. Okay, so let's run this again. So I'm getting here positive sentiment with score as 0.6391. Okay, if I add some more information in this, and let's see how it's behaving. So I'm adding that the movie was cool, and the animation and the graphics were out of this world. Okay, so this is what I'm saying. Let's see. So if you see this our score getting improved. Why? Because this is small positive thing we have added, and later we are talking about much more positive sentiment, that the movie was good and the animation and the graphics were out of this world. So we are adding too much positive things in this, so that's why that is getting reflected in the score also. So we are getting here. Okay, so this is saying that this is 0.72, and if I add some more thing like I would recommend this movie, so now I'm getting some mixed answer. So it's 0.7. It's saying why? Because here it's not able to capture the long range dependencies. So that is one limitation of recurrent neural networks. So it's not able to, sometimes if we have very long text, then it will not able to capture the long range dependencies, and it will not able to understand the context exactly what it's saying. Okay. So recurrent neural network miss some information, so that's why we are getting here 0.7. So till here it's improving because it's able to capture the dependency, so we are getting here 0.72, and if I remove this thing also, then we'll get less, like this 0.63. Okay, so till here we are getting good. So this recurrent neural network is basically designed for small problem where we can process small sequence of text. It is not good and robust on long sequences. Okay, so that's one limitation of this. So let's take one negative example. So here I am taking the movie was good in first half. Okay, so I'm saying here the movie was good in first half. Okay, let's take this example only. Okay, and see what it's saying. So it's saying it's positive sentiment with 0.73. Okay, so 73.73 is the score it's giving, that it is positive. So let me add something like, but second half is worst. Okay, let's see what we are getting. So we are getting negative sentiment because of this thing, worst and things. So I hate it. If I add, so I hate it, it will add more negativity, because till here it's we have added that movie was good in first half but second half is worst. So it's giving 0.13 is the sentiment which it's saying. But here if I'm adding this thing, so I hate it, then it's giving more negative. So it's giving much less score, close to 0, because here we are getting already, we are saying that second half is worst and I'm hating it. So too much negative things we have added in the text. So that's why we are getting here 0.09 as negative sentiment. Okay. So this is all about the testing. So you can play with different text and you can see how models behaving. And if you are not getting good result or you are getting something wrong, then also you have to do research. What are the things, why it's giving this? So there are some limitation of recurrent neural network also. So because of that limitation, we saw here that if we are adding too much information, then it's not able to improve its sentiment. It's getting some mixed answer, and somewhere it's taking averaging the score, something like that it's doing. Okay, so this is one limitation, that it is not able to process long range dependencies because of sequential chain. It is processing sequential information. So because of that, it's not able to process and retain that much information for a long time. So something like that is happening. Due to that, we are getting here something mixed response. So that is limitation. Okay, so let's move forward, and I will add here model evaluation. So let's evaluate our model also here. So model evaluation I will give here. Okay, and I'm removing this. I have to give code. Okay, so model evaluation, what type of model evaluation I want to do? So first is I will write here precision, and second is recall, and then is F1 score, and then is confusion matrix. So these are some model evaluation other than accuracy which we can do to check our performance of our model. So for that, first I have to take X test. Okay, so this is my X test, and then I have to do prediction. So first I have to, for the prediction, I have to convert it into same type of thing, like here we have converted this in NumPy array, and then we pass in this model.predict. So if I show you the type of this, so this is of pandas series type. So first we have to convert it into list, like here we are passing in NumPy array, this list we are passing. So same we have to do here also. So to convert this X test into list, you can use toList because it is pandas. So you can use like this toList, and if you do like this, then you will get this thing in list form. Okay, so this you have to pass in your model.predict. If I am doing, it will give you prediction. So if you do, then you will get the prediction. So we are getting like this. You can record this in ypred. Okay, so this is your ypred, And after that, we saw here that if it is greater than 0.5, then we have to say 1, else it is 0. So that we have to do here. So ypred you can write here binary. So in binary form we are changing it. So I'm writing here like np.var I'm using, and I'm passing here ypred, and what I'm saying, ypred greater than 0.5, wherever it is greater than 0.5, say it as 1, else 0. So this is what we are saying. And if I print here ypred binary, then you will get your ypred binary. Okay, so this is one way you can convert this into zeros and ones. So I'm saying here that wherever you find ypred greater than 0.5, put that value to 1, else if you are not getting this, then put that as 0. If I show you the ypred binary dot shape, then this will be 12,500. Okay, so now you have to compute y true also. So if I show you the y test exactly, so this is your y test. Okay, so this also you have to compute in the same format, in this same array form you have to convert. So for that, what you can do, you can take directly like this. You can convert this y true is equal to np dot, basically here we are converting these things to numpy array form for further processing. If I'm taking y test dot to list, if I'm doing just like I did for the prediction, so what I will get, so if I do y true dot shape, so I will get something like this, but I want in this format. So it is a matrix having 12,500 rows and one column. Here we are getting vector, so I have to put this in one more list like this, so that it become matrix. Yeah, so now we are getting matrix, but this is transformed like it is having one row and 12,500 column. So we have to take transpose of this. Okay, so now we'll get this like this. So now this is 12,500 cross 1 matrix. So we got our y predict, we got our y true. Now we are ready for computing precision recall F1 score. So you can give here one markdown as computing precision recall F1 score. Okay, something like that you can give here. Okay, now you have to use scikit-learn for this. Use from sklearn, sklearn.matrix you can use, and from sklearn.matrix you can import confusion matrix, you can import classification report. Okay, and also you can import confusion matrix display this thing. Okay, so you can write here also and confusion matrix. Okay, so we got everything which we want. So I'm using disp is equal to confusion matrix display I'm using, and in this you have to pass confusion matrix directly. So you can pass your confusion matrix directly using confusion matrix, and in this you can give y true, and second thing you can give ypred binary. So you can plot it like this, display dot plot you can use. So this is how you can plot. So I am removing this, so this is this, or you can write here display, so it will be also like this, and you can plot. So you will get your confusion matrix. So this is your confusion matrix, and if you want classification report also, so you can use classification report, and in this also you have to pass this y true and y pred. So you can pass like this here, y true y pred, and you will get your classification report. So this is for class 0. So for negative prediction, precision is 0.87, recall is 0.89, and for positive prediction, precision is 0.89, recall is 0.87. So overall it is 0.88. Okay, so this is F1 score, and this is a macro average of precision recall F1 score and support, and this is a weighted average. So this is what we are getting, and this is the confusion matrix in which this many number of example we have, which is being classified in zero class, and it is actually belongs to 0 class. Okay, and same we have here for positive examples. 5,473 examples are there having positive prediction and positive label same, and these are some labels which are not classified correctly. So 670 examples are there which are actually positive, but they are getting predicted in negative. So actually model saying that these are negative, but actually it is positive. And for 827 examples are there for which model is saying that it is negative, but actually it is belongs to positive. Okay, so this is how you can analyze and understand, okay, how model is behaving on test set. Okay, because accuracy is not only the measure using which you can come to some conclusion, so it requires these things also, like classification report and confusion matrix, which will tell you that how it's behaving on each classes, how your model is performing. So this is how you can use confusion matrix and classification report in NLP also. So these are the measures using which you can measure the accuracy. Okay, so I think we done too much things in this. So that is all about version 1 of this project series. So in this version 1 we first started our project. So first we saw that how we can install TensorFlow using Conda, and then we also need NLTK and Beautiful Soup, and then we started our project. So first we need this stop word and wordnet from NLTK, so we downloaded it, and then we did some data pre-processing. So we discussed about text processing in detail in the second video of this project series. So if you want to know in detail about how these things works, then you can watch the second video of this project series. And after that we applied those pre-processing things to our data frame, and this is what we are getting. And after that we got our pre-processed x and pre-processed y, and then we splitted this x and y in training set and test set. And after that we computed average number of tokens, which is average number of words present in each examples. So based on that we decided this sequence length and vocab size. And vocab size we have taken 20,000, because if we take more vocab size then it will make our model slow, so we have to spend too much computation on this. And so this is a good one. I have already experimented on different vocab size and I am not getting much improvement in increasing the vocab size, so that's why I have taken here 20,000 vocab size. Okay, and after that we saw that how we can build vocabulary using this vectorized layer. So this vectorized layer is basically the tokenization in context of generative AI. So this is a tokenization which we are doing here. So tokenization meaning that we are converting each word into unique numbers, which is an index of vocabulary list, and we are taking that index and we are using these index to build our embedding layer. So in this we are passing length of vocabulary, and this embedding layer will accept this unique number as input, and it will give you embedding like this. So this is what we saw, and after that we combine all these things in one pipeline where we are feeding text as input, and we are using vectorized layer, we are using embedding layer for further processing and creation of embedding. And once embedding is created, after this step we are feeding those embeddings to LSTM model, followed by this dense model, which is dense neural network. And after that this is my output layer. So this is how we are performing training. And then we have added these things, binary cross entropy and all. And then we also saw that how we can use early stopping to get the best model from the training. So that is what we saw here, that we stopped at 8 epoch, but we have selected this sixth one because this sixth one having least validation accuracy out of this all. Okay, and after that we saved this model, and we did visualization to see how model's accuracy is behaving with respect to each epoch. And also we saw that this is how you can reload your model and do prediction. So this is what we are getting. And after that we also saw that there are some limitations also of recurrent neural network, which we practically see by applying those things here. So that is the main aim of building these types of projects, so that you can do practical and understand. If you read somewhere, then everywhere on internet is written that transformer is better than recurrent neural network. There are some limitation of recurrent neural network, so that's why we are using transformer, because it solve long range dependencies problem, it has self attention mechanism. So these things are written on the internet, but you have to understand how things work, why recurrent neural network is not able to process things. So this is the example. So this, that, and then we did this model evaluation and then confusion matrix. So this is what we are getting. Okay, so that's all for this version 1. So in the next video, we'll create version 2 of this project. So where we will try to improve our model's performance using recurrent neural network only. Okay. So that's all for this video. I hope you like this video. Thank you guys. Thanks a lot for watching this video.